The hydraulic jacking system provides the thrust required to move the microtunnel machine and pipe through the earth. Jacking systems are available in a wide range of sizes, capacities, and configurations, from 200 tons up to 4,000 tons. The hydraulic jacking system is located at the rear of the drive shaft. After a section of pipe is placed on the guide rails, the jacks are slowly extended, powered by an hydraulic power pack on the surface. The force of the main jacks and the speed at which they extend is carefully synchronized with the excavation rate of the microtunnel machine. A thrust ring and pipe ring adapter ensure that uniform thrust is transferred from the jacks to the pipe. Thrust at the rear of the jacks is transferred to the thrust wall through pressure plates. Jacking systems can be either long-stroke jacks, jacking a complete pipe length in one push, and normally requiring a larger drive shaft, or, in order to accommodate smaller shafts, short-stroke jacks, together with spacer blocks, and a variety of indexing systems using multiple strokes of short-stroke jacks. These latter two systems achieve the same goal, pushing an entire segment of pipe while consuming smaller footprints and permitting smaller-sized drive shafts. The jacking force required to thrust the pipeline forward is mainly a function of frictional forces built up around the pipeline. This load depends on many factors and is generally calculated based on the square footage of the external circumferential area of the pipeline. As the length of the drive increases, so does the total friction produced between the pipe and the earth, thus demanding a greater jacking force. To reduce this friction, a clay-based or polymer lubricant mixed in a lubricant mixer on the surface is injected into the annulus between the pipe and the surrounding earth. Lubricant is always introduced immediately behind the microtunnel machine through a lubrication port in the machine. For larger machines and longer drives, lubrication ports are also provided at regular intervals through the wall of the jacking pipe to provide continuous lubrication around the pipe. This technique results in a considerable reduction in friction. Thus, the required jacking force is reduced, and longer jacking lengths are achievable. However, at some point during a relatively long drive, the required jacking force may exceed the capacity of the main jacking system, or the structural capacity of the pipe or thrust wall, requiring the introduction of one or more intermediate jacking stations, or interjacks. These interjacks provide additional jacking capacity and redistribute the total required jacking force at regular intervals along the length of the pipeline. Interjacks consist of a number of smaller hydraulic jacks assembled around the inside surface of an interjack canister. Interjacks are placed between sections of pipe and moved forward with the pipeline in the normal way until their operation becomes necessary. At such time, the first interjacks are opened, thus moving forward the microtunnel machine and the front section of the pipeline. Then the main jacks in the drive shaft are actuated, causing the closure of the interjacks while advancing only the rear section of the pipeline. This sequence is repeated for the duration of the drive, and upon completion, the interjacks are removed and the pipeline closed up, leaving in effect a standard pipe joint.